Hello everyone, welcome to the problem session from Gauss's law. This is the problem. In this problem it said that an electron is shot directly towards the center of a large metal plate that has a surface charge density minus 2 into 10 to the power minus 6 coulomb square. If the kinetic energy of the electron is 1.6 into 10 to the minus 17 joule, and if the electron is to stop just as it reaches the plate, how far from the plate must be the launch point be? Say this is the plate which has a surface charge density. We can write this surface charge density is sigma, which is given minus 2 into 10 to the minus 6 coulomb per meter square. An electron is, say, the launched from here with the initial kinetic energy towards the center of this plate, right, toward that direction. And since this is the electron is started with the kinetic energy which is Ki, that's given, which is this Ki, the kinetic energy, initial kinetic energy is 1.6 into 10 to the minus 17 joule. So as it moves towards the center of this plate, it's going to be the de-accelerated, right? Since this is actually that negative, this plate is negative charge, so that's why that if I draw the electric field would be towards that direction, towards the direction of the plate itself, right? So that will be the direction of that electric field. And we know that a positive test charge will move in the direction of the electric field and the negative charge will move towards the opposite direction. So that's why the force on the electron would be towards that direction. This would be that force on that electron, but it will move towards that direction. So basically it will be de-accelerated, right? So, and it is going to be stop over there. Now they ask you, if we start from there and stop over there, what would be that value of x? Fine. To solve this one, basically what we are going to do, we can find out that one using that work energy theorem. Basically we can write down work done, net work done would be basically change of kinetic energy using that formula, right? So this work done would be basically this is the force on that electron, electrostatic force, and the displacement which is x, and the angle between these, basically the cos of 180 degree, must be equal to kinetic energy final minus kinetic energy initial. And kinetic energy final is basically the 0, right, because it stopped over there. Fine. And cos of 180 degree, basically the minus 1. We'll find out that fx would be basically minus ki. Now this minus 1 will be cancelled out, and this f would be basically the q into E, which is the electric field, x into ki, right? Now if we want to find out this distance, then this x would be ki divided by qe. Q is the charge of that electron, ki is the kinetic energy, and E is the electric field. Now this electric field, we have to find out the electric field for this plate, metal plate. Fine. So this is actually equation number 1. Now to find out that electric field, since it said that a metal plate has a surface charge density sigma, and we define that surface charge density basically charge per unit area, right? So we have to find out this. Definition we find a charge per unit area. This is actually surface charge density. then we can say that total charge would be basically Q into A. Now if we want to find out that electric field for this metal plate, we have to use the Gauss's law. So what is that Gauss's law? We're going to use that Gauss's law. So close integration of E dot dA must be equal to Q enclose divided by epsilon naught, right? So this is actually the Gauss's law we are going to use. Now since it's a metal plate, we know that the charge on this plate would be basically at the top surface, right? Say I can use the different color for the metal. So it's a we can consider this would be basically the conducting surface. So that's why this would be that charge would be at the surface, upper surface. You can say that there will be no charge inside that. So that's why if you consider a closed Gaussian surface, say this is a closed Gaussian surface for this one, and say for that one, inside and outside, then the electric field into inside where there is no charge must be equal to the 0, right? Since there are no charge lower surface, which is inner side, left side, you can consider the charge would be basically the right side, which is upper surface. So then we can say that this electric field would be towards that direction, right? This will be the direction of the electric field, and this will be also for that area vector. Now if you consider this surface has no electric field would be the 0. This curved surface has no electric field also, because if you consider this is your area vector and this is also direction of that charge. So that's why you will not find out any electric field also, that it would be basically E dot A, angle is 90 degrees, so that's why this would be 0, right? So we will find out only for the electric field for this surface. This surface has also no electric field because angle is 90 degrees. So that's why we are going to find out the electric field for that one. We can find out that electric field. So if we write, so this would be enclose, and the angle E dot dA basically for that surface, for this surface, electric field and that area vector are parallel to each other. So that's why angle is 0, cos 0 basically the 1. And we'll find out enclosed charge. So we consider that enclosed charge is basically the Q divided by epsilon naught. Now what we can find out is, if you integrate the dA, we'll find out basically that area, right? And this Q we can replace by sigma A from this equation, because we define the surface charge density, charge per unit area, divided by epsilon naught. Now if you integrate that dA, we'll find out that A. So in that case it would be A sigma into A divided by epsilon naught. Now you can cancel out this area from both sides. Then you will find out that this E would be basically sigma by epsilon naught. So this would be actually the electric field for a metal plate. So now we are going to use this one basically into that equation number 1. So now we can find out, now from equation 1 we can write that x would be Ki divided by Q into E, right? So E is basically sigma by epsilon naught, so I put the epsilon naught over here. Now we can plug in that value. So Ki is kinetic energy, which is actually 1.6 into 10 to the minus 17 joule, and that epsilon naught is 8.85 into 10 to the power minus 12, and charge of the electron is 1.6 into 10 to the minus 19, and surface charge density, which is given, that is 2 into 10 to the power minus 6, right? Now we can find out that x would be, if you solve this one, you will find out that this distance would be 4.42 into 10 to the power minus 4 meter. So that would be the answer of this question. So this is that answer of this question. Okay, thank you very much.